Now, if you're trying to find the functions that are annihilated by these operators, then you can factor and because d is a polynomial, just d to the first, d to the first differential operator will annihilate a polynomial of degree 0, and d plus 4, anything in the form of d plus or minus something, will annihilate an exponential function. That actually annihilates e to the negative 4x. So this will annihilate something like a constant. X to the 0 is a constant. Plus e to the negative 4x. And you could have any constant multiplied by this. So I could put a c1 there and a c2 there. And notice that on a, if I apply this, d squared plus 4d to my c1 plus c2 e to the negative 4x, then that's the same as the second derivative of c1 plus c2 e to the negative 4x plus 4 times the derivative of c1 plus c2 e to the negative 4x. Here I need to take two derivatives, so applying one derivative will still keep me with 1, and applying one derivative gets rid of this constant. And on the second term it brings down that negative 4, so I get negative 4 c2 e to the negative 4x plus 4. Taking my derivative on this term, again I'm doing the derivative which I applied here. It's going to give me negative 4 c2 e to the negative 4x. And then here I apply the derivative one more time. So I'm bringing down another negative 4, so I get 16 c2 e to the negative 4x. Multiplying here by 4 gives me a negative 16 c2 e to the negative 4x. And notice that gives me a 0. So that checks my answer. In this case, I need to try and factor this. I'm going to write that 10 as 9 plus 1, so that d squared minus 6d plus 9 is a perfect square. It factors into d minus 3 squared plus 1, and this will annihilate something in the form of e to the 3x cosine x plus sine x, c1 cosine x plus c2 sine x. You can verify that down here. If I have d squared, this is on b, d squared of e to the 3x c1 cosine x plus c2 sine x minus 6 times the derivative of, e to the 3x c1 cosine x plus c2 sine x plus 10. Let's see what that gives me. Here, when I apply the derivative, I need to use the product rule, and I'll still be left with one derivative left. So doing my derivative the first time, taking the derivative of e to the 3x will give me 3e to the 3x, and then the c1 cosine x plus c2 sine x just carries along. Plus e to the 3x times what I have inside parentheses. The derivative of c1 cosine x plus c2 sine x is going to be negative c1 sine x plus c2 cosine x minus 6 times this derivative again. So here I can copy down what I've just done. And when I copy it, why not factor out my e to the 3x? Might save me a little bit of space. And that'll leave me with 3c1 cosine x plus 3c2 sine x minus c1 sine x plus c2 cosine x. And that closes that parenthesis and the bracket, and then I have plus 10. So now here I'm taking the derivative of everything that I have here, and I'm actually going to use what I have inside the brackets here because it's equivalent. I'm going to use the product rule. I'm going to keep the e to the 3x outside, and then inside I'm going to multiply everything here by 3. That'll be e to the 3x times 3. That's going to give me a 9 c1 cosine x plus 9 c2 sine x minus 3 c1 sine x plus 3 c2 cosine x. Okay, that's the derivative of e to the 3x times everything in parentheses. Now I need to add that to e to the 3x times the derivative of everything in parentheses. So I'm going to keep that e to the 3x factored out, and I'm just going to add on my derivatives here. Adding my derivatives, the derivative of 3c1 cosine x is negative 3c1 sine x let me line up like terms, minus 3c1 sine x. The derivative of 3c2 sine x is going to be 3c2 cosine x. The derivative of negative c1 sine x is going to be negative c1 cosine x. And the derivative of c2 cosine x is negative c2 sine x. Okay, so that's my second derivative. And I've taken care of all of this now. Okay, now I want minus 6 times all of this. And so let me, again, because I have that e to the 3x factored out, let me keep that factored out and just keep combining like terms here. I'm going to multiply by negative 6 to get negative 18 c1 cosine x. It goes here, negative 18 c1 cosine x. Negative 18 c2 sine x. Negative 18 c2 sine x. This will give me a plus 6 c1 sine x. And plus minus 6 c2 cosine x. Okay, and that closes my bracket, and then I have plus 10 at the end. So notice that when you combine your terms, these terms all cancel each other out. They're all like terms. Negative 3 gives you negative 6, plus 6 cancels. All of these terms cancel each other out. I'm going to be left with, see, I have 9, take away 1 gives me 8, minus 18 gives me negative 10 c1 cosine x. 9 take away 1 is 8, minus 10 gives me negative 10 c1 sine x. And then plus 10. Now what I'd forgotten was that these are simple operators. There we go. These are simple operators, and they get applied to some function. And so that 10 isn't just 10, it's 10 times y, or 10 times whatever your function is. 10 e to the 3x. c1 cosine x plus c2 sine x. And that carries down here. I'll just call that y. And here I forgot to include my e to the 3x that was factored out initially. And you can see that these do cancel out. And those do cancel out to leave you with 0 as the remainder. Now notice in step 1 when we factored here, we used each factor to come up with a separate function that we could annihilate, and those functions are added together. Do the same thing here. If you've got just a polynomial factor, then the function that you're going to annihilate is a polynomial. So a second derivative will annihilate a first degree term. So you've got a first degree term, something like ax plus b. That'll be annihilated by your d squared. Plus, if you have something, a differential operator that looks like d plus 4 or d minus 5, these type of differential operators will annihilate exponential functions. Okay, so I'm going to let my coefficient be c, and a d plus 5 will annihilate e to the 5x. D minus 7 will annihilate e to the 7x. And so here a, b, c, and d are coefficients, and these differential operators should annihilate anything in this form.